Right now, humanity is searching for another planet to live on. Billions of dollars, thousands of scientists, decades of work, all pointed at one question. Is there somewhere else we could go? But most people, when they hear that, picture science fiction, rockets and colonies in some distant future that probably won't happen in their lifetime. What they don't picture is the real reason this search is happening. Because the real reason isn't adventure. It isn't curiosity. It isn't even the desire to explore. It's survival. And the timeline is shorter than almost anyone wants to admit. Let's start with what we know about Earth. Not the political version, not the optimistic version, but the version that the data actually supports. Earth is a closed system. Every resource on this planet is finite. The metals we use to build our technology, the phosphorus we need to grow food, the fresh water that sustains every living thing. All of it exists in fixed amounts. And we are using it
faster than any natural process can replace it. In 2019, researchers at the University of Technology, Sydney, published an analysis projecting that several critical minerals essential for modern electronics and clean energy technology could face severe supply constraints within decades, not centuries. Decades. The rare earth elements that power electric vehicles, wind turbines, and smartphones are concentrated in a handful of locations globally, and demand is accelerating faster than reserves can support. This isn't a future problem. It's a present one that's being quietly managed by geopolitics rather than solved by science. But resources are only part of it. The deeper issue is risk. Extinction-level events are not science fiction either. They're geology. The fossil record shows clearly that mass extinction events have happened multiple times in Earth's history, caused by asteroid impact, by volcanic activity so sustained it changed the atmospheric composition of the entire planet, by shifts in solar output, by magnetic pole reversal. Any single one of these events occurring today could end human civilization as we know it. The Chicxulub impactor that ended the age of dinosaurs 66 million years ago released energy equivalent to roughly 10 billion Hiroshima bombs. We do not have a reliable deflection system. In 2022, NASA's DART mission successfully redirected a small asteroid in a test, which was genuinely historic. But the honest assessment from planetary defense scientists is that we currently have no guaranteed method to stop a large asteroid on a short warning timeline. And asteroids are arguably the most manageable risk. They can, in theory, be detected and addressed. The risks we can't manage from inside a single planetary system are another category entirely. A nearby gamma-ray burst, a shift in our sun's behavior over long geological timescales, a supervolcanic event of the kind that nearly collapsed human population approximately 74,000 years ago at the Toba catastrophe. These aren't speculative. They've happened before. The argument for finding other planets isn't that Earth is doomed next year. It's that confining all of human civilization to a single point in space is by any reasonable risk analysis an extraordinarily dangerous long-term strategy. Physicist Stephen Hawking said it plainly before his death in 2018. He estimated that humanity has roughly 1,000 years on Earth before a catastrophic event makes it uninhabitable, and that survival as a species requires becoming multiplanetary within that window. Other scientists have disputed the timeline, but almost none dispute the underlying logic. A species that exists in only one place is a species with no backup. So, what does finding another planet actually require? It starts with detection. Since 1992, when astronomers confirmed the first exoplanet orbiting a sun-like star, we have identified over 5,000 confirmed exoplanets. The Kepler Space Telescope alone found more than 2,600 of them. The James Webb Space Telescope, operational since 2022, can now analyze the atmospheric composition of planets orbiting distant stars, looking for signatures of water, oxygen, and conditions that might support life. In 2023, astronomers using Webb data detected carbon dioxide and possible sulfur dioxide in the atmosphere of a planet 700 light-years away. Not a confirmation of life, but a demonstration that we can now read the chemistry of another planet's air from across the galaxy. The challenge is distance. The nearest confirmed potentially habitable planet candidates orbit stars 4 to 40 light-years away. At current spacecraft speeds, reaching even the closest would take tens of thousands of years. The search for other planets is therefore not a search for somewhere to move to next year. It's a multi-generational project, the beginning of a process.
Future versions of humanity will need to be far further along than we are. What drives it right now, in practical terms, is threefold. It's insurance against extinction. It's the pressure of finite resources on a growing population. And it is, underneath everything else, the recognition that for the first time in Earth's history, one species has developed the cognitive and technological capacity to leave the planet it evolved on. Every other mass extinction in Earth's history happened to species with no choice. They could not see it coming, and they had no means to respond. We can, and we do. The question is whether we'll act on that capacity before we need to, or only after it's too late to matter.